Alright, this video is meant to help you understand how to solve equations dealing with roots, or basically what we call radical equations. Remember that another name for that square root symbol is the radical. So if an equation already has a radical in it, again, we're going to essentially take the same approach we did with square root equation, or with quadratic equations, sorry. If something was squared, we could take its square root. Well, in the same sense, if it has a square root, then we can square to get rid of it. However, it needs to be isolated first. If I square right away in this first equation, the square root of x minus 7, which you have to remember is, if I try to square both sides, I'm actually squaring the entire side, which means that I would end up with a binomial square, and now I'd have to expand that equation. And you're not going to end up getting rid of the root. If you set those side by side and FOIL it out, you're not actually going to end up getting rid of that middle term. So what we would want to do is go backwards here. Let's get rid of all that extra writing, and let's isolate the root first. We'd want to get square root of x all by itself. So the first step I would take is let's add 7 to both sides. By doing so, we've isolated now. Again, minus 7 plus 7 becomes just the square root of x on the left, and a positive 7, 0 plus 7 is 7, on the right. Now we are fully ready to go ahead and square both sides. Now I can square the square root and square the 7, and x, because square root squared cancels, will end up equal to 49. And if I took 49 and put it back in, again, the square root of 49 would have been 7 minus 7 gives us 0, and that is a good answer. So the same thing happens when there's a little bit more going on over here on the right. It looks like there's a little bit tougher problem, but really it's the same essential idea. We've got that plus 3 on the outside, which is the first thing that we want to get rid of. If it's outside the root, it's fairly simple to get rid of. Then we're going to go ahead and square both sides, because once that root was isolated, we can go ahead and have 2x minus 3. And again, that square in no way affects what's underneath. Square root squared canceled, and what was already underneath here just carries down. 1 squared is 1. And then 2 quick steps. I'm going to add 3 to the other side and divide by 2. And I'll end up with a good answer there. And I'll know it's a good answer because, again, we're solving equations. We can take that 2 and plug it back in. 2 times 2 would have been 4. Minus 3 is 1. Then we take that big square root. Square root of 1 would be 1, plus 3 is 4, and we get a good answer. So let's go ahead and take that same approach to these two problems. Now these two have a slight twist to them. The one on the left, we've got multiple square roots going on. The upside for us, or the nice part, is that each of those square roots is essentially isolated by itself. So if I start off right away saying, hey, 2x minus 1 squared, and the square root of x plus 4 squared, then we can right away just cancel those roots. Again, all that happens is the roots disappear, and then we just solve from there. I'm going to go ahead and add this 1 over to the right side, and at the same time subtract that 1x over to the left. Well, 2x minus 1x, right, adding 1 over here. Again, I got the 5, those 1's are gone. X's on the right are gone, but I get x on the left. And now I can take that 5 and again check my answer. 5 times 2 would have been 10, minus 1 is 9, square root of 9 is 3. And 5 plus 4 is 9, square root of 9, also 3, checks. And we've got our answer. Now the equation at the right seems fairly basic. However, it has a very large twist to it. If I take the square root of x equal to negative 9, then we square both sides. Right? Square root squared becomes x, and negative 9 squared becomes 81. The one trick is, though, when you take the square root of 81 back at the beginning, square root of 81 would have been 9, which then is added on to 9, and unfortunately 18 does not equal 0, and therefore this is an extraneous solution. And if the only answer you get does not work, then we say no solution. and that would be our final answer. Sorry about the handwriting there. Make sure you're checking your answers. It's very important, especially with square root equations. The minute that we square both sides of an equation, we're essentially making this a quadratic equation. We're placing at least two answers into our equation. So when we end up with one answer and it doesn't work, it just means that one of the answers we introduced, maybe we made an answer that didn't actually work at the very beginning. So you have to be a little bit careful there. Go ahead and try the 4 problems here on this next screen. I'm going to pause the video now, and it'll come back in just a minute or so. It'll have all the correct answers laid out for you, and you can see kind of how these problems would flow together. All right, so here are all the answers for you. Again, the equation in the upper left is a fairly straightforward one. Again, handle anything on the outside of the root first. So notice the first thing that we did was added 6 over the other side to make 8. Then it was a matter of getting rid of that square root. So the next thing I would do is square both sides, leaving me with 3x plus 1. 8 squared is 64. And then a couple quick steps, just subtract the 1, divide by 3, and we end up with 21. If you plug it back in, 21 also works. So we go ahead and circle that. That's a perfectly good answer. On the bottom here, notice we had 2 square roots again. It was helpful to get them on separate sides, though. Notice that one of them is being subtracted. The upside for us is we're just adding to 0 on the other side. So I went ahead and added the entire square root, therefore making it a positive square root of x plus 21 over on the right side. Then I squared both sides, leaving me with a fairly simple equation. Again, subtract the x, add 17, and divide by 2 to finish. And we end up with 19 for a good answer. Again, check that answer. It will work. Then on the right, we kind of had 2 of them that, again, turned into quadratics. The minute you take that thing squared, there's a chance, again, you're making this thing quadratic. You're making it more tricky than it kind of started off being. But they kind of finished in 2 different ways. You'll notice I squared the one on the top here. So we've got 3x plus 4 equal to x squared. And then, now that that's x squared, well, it's a quadratic equation. Let's go ahead and solve for 0. And it went ahead and factored x minus 4 times x plus 1. Well, so by zero product property, that means that 4 makes the first quantity 0. So that's one of my answers. And negative 1 would make the other quantity 0, thus the whole equation 0. And that's my other answer. However, when you plug them back in, 4 works. 4 would be 12, plus 4 is 16. Square root of 16 is 4. So previous to having squared that equation, right, previous to that happening, 4 equals 4. But now if you plug negative 1 in, negative 1 times 3 would be negative 3. Plus 4 is a 1, and the square root of 1 is 1. However, negative 1 is what we're plugging in on the right side. So 1 equals negative 1 does not exist, does not work. Negative 1 is an extraneous solution. Therefore, 4 is the only good answer. On the bottom, the same idea happens. You square both sides, you get solve for 0, you factor, and you find out 2 answers, 2 and 1. Now, it just so happens that when you plug 2 in, that's 4 minus 2 is 2. Or sorry, 6 minus 2 is 4. The square root of 4 being 2. And again, that equals our answer, 2. And if you plug 1 in on both sides, again, 1 makes 3 minus 2 is 1. Square root of 1 is 1. And they both actually work. So again, it's very important you check your answers. Make sure you're comfortable with all those situations. If you have any questions, make sure you talk to your teacher. Otherwise, good luck, happy solving equations, and have a great day.